This is for Year 12 Methods. It comes out of the 2016 VCAA exam 2, question number 4. It's about hyperbola, so I need to express this in terms of this form. So I've got 2x plus 1, x minus 2, interactive, transform, fraction to a proper fraction, and I get 2 minus 3 on top of x plus 2 is what 2x plus 1 over x plus 2 equals. Therefore a equals 2 and b equals negative 3. Let this be the domain for this particular hyperbola, which is that one. Find its inverse. So if I take this, get rid of the bracket, and I'll make it equal x, and I change the x to y and the x to y, and I go interactive, advanced, solve for y, and I put that together. I get the inverse equaling 1 minus 2x over x minus 2, and if I was to put that into an improper fraction, it's going to be also equal to minus 2 minus 3 on top of x minus 2. And I've got to find the domain. The domain will be the range of the original, and the range of the original will be all real numbers except for 2, the same as its domain, but it's its range because it has an asymptote at 2. So it'll be everything except 2. Here is a graph of f and y equals x. Find the area of the shaded region. So this is f of x. So if I go back up to the top and grab f of x and paste and make it equal to x, I can then solve for x. And that tells me that it's negative 1 and 1, so that's at negative 1. And that's at 1, so it's the integral from negative 1 to 1 of f of x minus x dx. So if I select f of x, the top one, minus x, and I select it, interactive calculation, antiderivative, definite integrals, lower is negative 1, upper is 1, and go OK. My answer is going to equal 4 minus 3 log base e of 3 square units. If I'm looking for the shaded region of this, well, if I put my line of y equals x, that's what I got on the last part. So the area will be 2 times whatever I got last time, which was 4 minus 3 log base e of 3 square units, or 8 minus 6 log base e of 3 square units. Okay, so that should be part of the graph is shown here. The point CD is on the graph. Find the exact coordinates of C and D such that the distance from the origin is a minimum. So the distance of CD is going to be the square root of point CD, let's call it C, and D will be if C is placed into this rule, so 2C plus 1 and C plus 2 is the coordinate. So C minus 0 squared plus 2C plus 1 over C plus 2 minus 0 squared, and that will be the distance. And that gives me this. So if I take that answer and I take its derivative, and I take that answer and I set it equal to 0 and solve for x. So I get these two answers. This is the one I want because this will be negative, whereas this answer will also be negative. So which one do I want? Let's have a look at these answers in decimal form. Negative 7's no good because that's all the way over here, but negative 0.2 is the one that I want. So in actual fact I want this one here. So C equals root 3 minus 2, therefore D equals, if I go back up here to the expression for hyperbola, and I place that there, and math 3 given x equals this, gives me the D value as being, and if I simplify the answer, 2 minus root 3. So that's those coordinates. Find the exact values of C and D such that, okay, that's what I did. And find the minimum distance. The minimum distance will be, if I take that and I find that distance expression, not the derivative of it, there it is there. That is the distance expression, copy and place it at the front. Get that answer, when I simplify that answer, I get an answer which is the minimum actual distance, and the minimum distance will be distance equals square root of 14 minus 8 root 3 units. And that's the answers to A, B and C.